Hello and welcome to the logic of it all. In this video, we are going to talk about two logical connectives, namely disjunction and conjunction. Let's start with conjunction. So we have two propositions, P and Q. Their conjunction, which is denoted like this, P and Q. So this symbol here is the symbol AND in logic. So P and Q are two propositions, and then we combine them to create a compound proposition that is called P and Q. And that is called a conjunction. So for example, if P is the proposition that September is the 7th month of the year, and Q is 24 is an even number, so P and Q, you can check both are propositions, which means that they have a definite truth value, either true or false. Then P and Q will be the proposition, the compound proposition that states September is the 7th month of the year and 24 is an even number. So remember from the previous video we talked about compound propositions. So the way to create them is by using these connectives, and the first connective that we learned about is conjunction, which is also called AND. Now the first question here is, how can we know about the truth value of the compound proposition P and Q? And obviously, the truth value of P and Q depends on the truth value of P and the truth value of Q. Each one of them can be either true or false, so we have overall 4 possibilities. It's either that both are true, it could be that P is true or Q is false, it could be that P is false and Q is true, and finally it could be that both of them are false. So we have 4 different scenarios depending on the truth value of P and the truth value of Q. And the compound proposition P and Q is going to have a truth value depending on which one of these 4 cases we are in. Now usually we represent this in a table that is called the truth table, in this case for the proposition P and Q. The truth table in this case is going to have 4 rows because remember we had 4 possibilities. So each row in the table represents one of those 4 possibilities. So the first row is when P is true and Q is true. The second row represents the case where P is true but Q is false. The third row represents the case where P is false but Q is true, and so on. So 4 possibilities translates into 4 rows in the truth table. Now, if you think about the meaning of and you don't need to know logic to know this, but if you think about the meaning of and in any natural language, English or any other language, you realize that when you combine 2 sentences with an and, for that compound proposition to be true, both of the components must be true. In other words, for P and Q to be true, both P and Q must be true. And that is reflected in this table, as you can see, where P and Q is only true when both P and Q are true. If either one of them is false or both of them are false, then you see that P and Q will be false. So to summarize this, the conjunction of 2 propositions is true if and only if both propositions are true. And as we said, this is called the truth table for P and Q. Now, as we introduce more connectives, for each one of them we are going to have a truth table, and obviously the way that the truth table works depends on which connectives we are investigating. Now, as an example in programming, if we look at this pseudocode, so we have 2 variables n and m. N is initialized to 4 and m is initialized to 10. And then we have the third variable sum, which is initialized to 0. Now we have a conditional statement, and the condition of this if statement is a compound proposition, because we have this proposition here, let's call that P, which says n is less than 7. And then we have this other proposition here, let's call that Q, that says m plus n is greater than 18. Now if that is the case that n is less than 7 and n plus m is greater than 18, then sum gets updated to n plus m. Otherwise, sum remains unchanged. Now, what we need to do is we need to figure out this compound proposition P and Q, whether it's true or false. Now, what can we say about P? Is P true or false? P says n is less than 7, n is 4. Is 4 less than 7? Yes, it is. So this is true. Now, how about Q? What does Q say? Q says m plus n is greater than 18. Now, what is m plus n? 4 plus 10, 14 is greater than 18. Is that true or false? Obviously, that is false. So what we have here is true and false. And if you remember the truth table for conjunction, and if one of the propositions is false, then the whole thing translates to false. So to summarize, the compound proposition for this if statement is false, which means that the statement inside the if will not be executed, and as a result, the value of sum does not change, so the final value of sum will remain 0. Right. So now let's look at the second logical connective that we are investigating in this video, namely disjunction. So similar situation, we have two propositions named P and Q. Now their disjunction, which is represented this way, P or Q, is a new proposition, which is a compound proposition. So this is our symbol for or in logic. Now, as an example, if we consider P to be the proposition that the band The Clash formed in London in 1976, and Q is The Clash's first album is called The Clash. So we have two propositions, P and Q. Now, P or Q will be the proposition that says The Clash formed in London in 1976, or The Clash's first album is called The Clash. So it's very simple. And obviously, now we need to talk about the truth value of disjunction. And similar to conjunction, the truth value of P or Q depends on the truth value of P and also the truth value of Q. And again, similarly, we are going to consider 4 possibilities, all possible scenarios. Either they're both true, or P is true and Q is false, or P is false and Q is true, or they're both false. And similarly, we are going to create a truth table for P and Q with 4 rows where each row represents one of those 4 possibilities. But as I said previously, the truth value of our compound proposition depends on the connective that we use. So here we are using the connective or, and that is going to have a different rule than and. Now, again, you don't need to know this. You don't need to know logic to be able to figure this out. If you think about the meaning of or in any language and how it combines 2 sentences, you can see that if you combine 2 sentences or 2 propositions with or, for that compound proposition to be true, it's enough that at least one of your 2 sentences is true. So in 3 of these scenarios where P and Q are both true, or P is true and Q is false, or the other way around, in these 3 cases, their disjunction is going to be true. In other words, the only case where the disjunction of 2 propositions is false is when both of them are false. So when you combine 2 sentences with an or, you are wrong only when both of your sentences are false. If at least one of them is true, then the whole thing is going to be true. So you see, another way to think about this is we call this P or Q, but a better way to think about it is P or Q or both. So it is allowed that both of them to be true. So that is allowed in this definition, as we can see here on the first row, right? So this is the standard or, and for those of you who are interested, there is another version of this, another connective that is also called or, but it's called exclusive or. And in that case, exactly one of the P or Q needs to be true. So if both of them are true, then the exclusive or of them is false. right? So that's a different connective, and obviously it has a different truth table. So yeah, so this is how disjunction works. Now here's an example. We have two simple propositions. P is the proposition that says 2 plus 2 is greater than 5, and Q is the proposition that says Huddersfield is a town in West Yorkshire. So we have the compound proposition P and Q. The question is, what is the truth value of P and Q? Is it true or false? Now, if you remember, to be able to know this, we need to know the truth value of P and Q. Now, obviously, the first one, 2 plus 2 is greater than 5, that is a false statement because 4 is not greater than 5. And then if you look at the map, you'll see that Huddersfield is actually in West Yorkshire, so this is true. So here what we have is false and true. And we know that for conjunction to be true, both of these components must be true. And in this case, that's not the case. So this is false. Now the second compound proposition is P or Q. So false or true. And again, if you remember, for disjunction, for or, it's enough that at least one of the components is true. And in this case, the second one is true. So this simplifies to true.